Now I'm trying to tell you how to set up. So in that assignment, I already tell you where to copy the files, but that was on a COE machine. Audrey just helped to set up some new machine, so I may give you new information. But before that, just follow the instruction in the assignment, okay? So to use TCAD Sentaurus, I need to go to the TC shell, right? It is there. You don't need to really understand what it is. And then set up the variable. And I already put in the assignment, so you just set up the environment variable so that it can start, right? And then the first thing you want to do is to set up a working directory for the so-called SWB, Sentaurus Workbench. So this is a workbench manage your simulation. And what I need to do is to type set environment and then STDB and then my home directory, right? And then a folder that I have created earlier. So here what I did is I set the environment to STDB, right? And with this, then I type SWB. And it will bring me this. Wow. Okay. So this is the Sentaurus Workbench. And what you need to do is go to Help. And then you see the training. So this is also mentioned in the assignment. And what you need to do is like follow the training. I already tell you which section to go through, right? But here I will tell you some basic thing to make it easier for you at the beginning. Okay? So, but you still need to go through the training. So let me quickly, I'm not going to show the TCAD, right? So you just go through them, but here I can show you how to do some important starting. For example, there you will see this application library. In application library, there are many projects. So you are expected to use the project to start your assignment, to work on them. You don't want to build everything from scratch. For example, I go to Getting Started. All the HTML material have project inside this Getting Started part, right? This is just like Windows system. I can copy it easily. Let me try this one more time. Okay, good. Right, so for example, I will go to this so-called transport models. I need to double click it and then copy it to my local directory in order to run it. So it's just like Windows. There are some options to it. You right click here, and this right click the project, and then you choose copy. Right, and then go back to your directory. Right click again, and then choose paste. Then it will be copied to your local directory. So this is a typical SWB project. What it does is you always need to create a structure for it to simulate, right? As I said, DY simulator or a TCAD simulation is that you try to solve the physical equation in the structure you provide. So you need to create a structure. There are two ways to create a structure. One is use the so-called Sentaurus Structure Editor. Another is use Sentaurus process. Sentaurus Structure Editor is that I know what the final structure it is. For example, I know where is the drain, what is the doping, and how long is the gate. I just draw it, and then I will get what I want, right? Another is just that I don't know the structure, but I know the process flow. I provide a mask, and then I say implantation, diffusion, and then another implantation, add photoresist, strip photoresist, then eventually I get my structure. So they can do both. So one is structure editor. Here it uses structure editor, right? So for this project, I will just, do you see that I always need to double click the project to make sure that I'm running the project. When you double click this project, you see on this top, on the top here, you show me the path. Make sure that you are at that path. And then you can submit the job by clicking this run man. And you will start running the simulation for you. Okay. Now, for each icon here, it has a so-called master file. You can right-click the icon. As I emphasize one more time, this is just like window, right? You want to do something to a folder or to something, you can just right-click, then you can choose something that is applicable to it. Here, I right-click the SDE, then you show me many things. One of them is add the input. I click on this command, and then you bring up a window in which it has all the command for me to construct the device. And that's why I say you don't want to construct from scratch. You want to understand them and modify based on what we already have. Same for your project. For some of your project, it is not in the application library, but I have something for you to get started. Okay? And then you see this is just programming, right? Here we try to define gate length equal to 0.05. This is in micron, means the gate length is 50 nanometer. This is just defining the variable. After you define the variable, you do some operation, and then eventually you do some creation. For example, here I say, okay, I want to create a rectangle. The rectangle has this coordinate, x sub 0 and 0 y max. You give the opposite corner of the rectangle. Then you get the rectangle. And the material is silicon, and the name of the region is called R.substrate. So you give a name to every region and also give the material, right? So I keep doing this. I create the gate oxide. I do poly-reox, etc., right? After this are done, I will need to create a contact, right? So what is a contact? Contact is nothing but just a label. For example, you have, let me write on the board this time. I can do this. Yes. Oh, yeah, but now I realize, thank you. I realize that I should actually use paint brush, right? I will do it quick. I think we're done. For a structure, you actually, like this, right? You have a structure. You actually need to create a lot of mesh. These are the mesh points for your structure. And then the device is going to solve differential equation on this. For example, you're doing a Poisson equation, right? You do this equal to rho. Then you have to solve differential equation. So you have a lot of mesh point, right? So what is a contact? Contact in Sentaurus is nothing but just an additional identity to the node. For example, I call this group as source. So what does it mean? It means that it adds extra identity to this node. And then later I can say apply 0 volt to source. Then this will get 0 volt as the boundary condition to solve your device. And that's what you mean by contact. And you need to do this in order to solve your equations. Okay? So this is getting started, and I will continue again next time. Okay, thank you.